So, hello everyone, how are you all? I hope you all are fine and safe. Well, again, welcome back to Quantum Mathematics. I'm Aman, just welcoming you all to a new amazing video in which we are gonna be just proving an upgrade of my previous video. Well, from my previous video, you guys are sure about this thing. Natural logarithm of gamma of 1 plus x as minus Euler Mascheroni times x plus the sum as n goes from 2 to infinity of negative 1 to the n and Riemann zeta of n over n and times x to the n. Yeah. So you guys are sure about this from my previous video, right? So basically, using this only formula and a couple of later I'll use them, but this is the basic and foundation for which we are here for again actually. Okay, so basically we are gonna be proving this one from here to this thing, and it's natural logarithm of gamma of 1 plus x itself as 1 over 2 natural logarithm of pi x over sine pi x minus Euler Mascheroni minus 1 times x, and then minus 1 over 2 natural logarithm of 1 plus x over 1 minus x, and minus the sum as k goes from 1 to infinity of, you can say, it's the Riemann zeta of 2k plus 1 over 2k plus 1 and x to the 2k plus 1. So from here we're gonna be proving this amazing let's just say representation, because this is the this is also representing the natural logarithm of gamma of 1 plus x, right? And this one is also representing that function only, but with some extra stops, right? Including, you can say that this is quite relatable, you can say, because whenever I see something sort of that, I always remember the Euler's reflection formula as well as the Euler's sine infinite formula, and I have uploaded the proof of both things on my YouTube channel. So yeah, okay, and yeah, I'm done with this, and let's just talk about this one with the help of that thing only. So let's just talk about this. So, as I just told you that the formula that we have proved in our previous video is gonna be the foundation for the one which we are here for. So let me just write that formula again over here. So it's natural logarithm of gamma of 1 plus x. It is minus Euler Mascheroni times x plus the sum as n goes from 2 to infinity of negative 1 to the n, right? And it's Riemann zeta of n over n and x to the n, right? So yeah, let's just dive into it. Okay, basically we are gonna play around with this infinite sum. And how so? Let's just talk about this. So let me just take that as s. So s equals the sum, this very sum actually, to negative 1 to the n Riemann zeta of n over n and x to the n. Okay, well, you know what, if we are having a sum, whether it is infinite or finite, it doesn't matter anymore, but we are having a sum, so we can write that sum into two different categories, like adding both those categories actually, and the categories are even terms and odd terms. And you know, for even terms we have to plug n equals to k actually. Well, let's say n is being represented with 2k, so that's going to be representing even terms of this infinite sum. And if we talk about odd, so it's going to be 2k plus 1, right? And since the sum is n is going from 2 to infinity, so if you're going to write this a little bit, so basically it's going to be Riemann zeta of 2 over 2 x to the 2 and then minus Riemann zeta of 3 x to the 3 over 3, and then plus Riemann zeta of 4 over 4 x to the 4, and this keeps going up to infinity, right? So if we talk about even and odd terms, so this can be categorized as Riemann zeta of 2 over 2 x to the 2 plus Riemann zeta of 4 over 4 x to the 4 plus Riemann zeta of 6 over 6 and x to the 6, and plus all the way up to infinity. So these are the even terms, right? And if we talk about the odd ones, so that's gonna be this one. So I'm just gonna factor a negative because every odd term would be having negative in front of that, because you can see that it's an alternating series, right? So it's Riemann zeta of 3 over 3 x to the 3 plus your Riemann zeta of 5 over 5 x to the 5, and plus Riemann zeta of 7 over 7 and x to the 7, and this is just keeps going up to infinity, and we have factored that out. So basically, if we are gonna add this expression and this one, so that's gonna be giving us back this whole expression, because we just have divided this infinite series into two different series, and those are like even terms and odd terms, right? So if we are gonna write them, so basically this can be written as this sum as, let's say, k is going from 1, because look, it was n equals 2, so you might get confused that this should also be from k equals 2 actually, but it's not like that, because if you look at this, it's 2k, n is being replaced with 2k here. So basically it's Riemann zeta of 2k over 2k, right? And it's the denominators are the factors of 2, and the arguments of Riemann zetas are also the factor of 2, and even the exponents of 2, x are also factors of 2. So basically it's x to the 2k, and minus this very sum as k goes from 1 to infinity, because they are considering 2k plus 1 instead of 2k minus 1. So if we were considering 2k minus 1, so this sum would be beginning from k equals 0. Oh no, k equals 2, right? And that would be giving us the first term as Riemann zeta of 3, right? But we are beginning, we are writing odd terms as 2k plus 1. So for that case, we have to begin k from 1. And then only we would be having the first term as Riemann zeta of 3. So Riemann zeta of 2k plus 1 over 2k plus 1 x to the 2k plus 1. So yeah. So basically, I'm just gonna replace this sum with these two different, and you can say odd and even terms, sums actually you can say, right? So let's just do that. And yeah. And before that, oh, I'm sorry, I did forget something here. And before that, okay, by the way, let me just write that down, that the sum as n goes from 2 to infinity of -1 to the n, Riemann zeta of n over n, and x to the n is being represented with these two sums as k goes from 1 to infinity of Riemann zeta of 2k, x to the 2k over 2k, and minus this another odd term, actual odd terms, 2k plus 1 over 2k plus 1 and x to the 2k plus 1. Okay, so basically, yeah. And before that, well, I just explained you these sums, and before that, let me just do a little bit changes here. Actually, I just forgot that. I need to change that. Well, I'm just gonna play around a little bit with that. So we have natural logarithm of gamma of 1 plus x, right? And it's negative Euler mass times x plus sum. I'm just gonna add infinite sums that is going from n equals 2 to infinity of argument -1 to the n times x to the n over n, and subtract the same thing as well. So that's going to be giving us negative 1 to the n Riemann zeta of n minus 1 over n, and it's x to the n. And because we had just used the minus part of this, the one that I said earlier, so we have to plus the another sum, that is n goes from 2 to infinity of negative 1 to the n x to the n over n. And now we can use this very stuff over here. Well, you don't need to take care about, yeah, we are having negative 1 there, but you don't have there, so it's not gonna bother us, right? Because you just have to replace n equals 2k, and you are good to go with these two terms, these two sums over there. And but before that, let's talk about this sum, right? So yeah, we have Taylor series expansion. Taylor series expansion of natural logarithm of 1 minus u. It's minus times sum as k goes from 1 to infinity of u to the k over k. Right? So basically, yeah. And if we talk about, hey, wait a second. Wait. Did I just mess up? Oh, yeah, it's not natural logarithm. We have to talk about the natural logarithm of 1 plus u. So basically, it's negative 1 to the k, u to the k over k actually, right? So yeah, basically this sum is representing, well, it's going from k equals 1, and it's n equals 2, right? Basically, let's write this n equals n. Don't be confused. So basically, if in order to just make this sum from n equals 2, we have to write the first term of this one. So first term is gonna be your, actually it's my, hey wait, I'm just literally just messing up here actually. I'm so sorry guys. Let's take another look back to here. So Taylor series, we have natural logarithm of 1 plus x as the sum as n goes from 1 to infinity of negative 1 to the n minus 1. Yeah, I'm sorry about this. And it's x to the n over n, right? So if we talk about like the first term of this, so that's gonna be negative, wait a second, yeah, that's gonna be negative x, right? I'm just messing up, dude. Negative 1 to the x. Okay, yeah. So yeah. Oh, I'm so sorry, guys. I'm so sorry. I'm extremely sorry about that. I'm just messing up a lot. Okay, so basically we have to add. We have to multiply both sides by negative 1 in order to get rid of this negative 1 in the exponents after n, and that's gonna be giving us minus natural logarithm of 1 plus x equals x, because the first term is going to be x, right? And yeah, plus this sum as n is going from 1 to infinity of negative 1 to the n, because we had multiplied negative both sides, so we just got rid of this negative 1 actually in exponents. So when you plug n equals 1, it's negative x. When n equals 1, so that's going to be giving us negative x, and yeah, you just got that, right? And it's negative 1 to the n times x to the n over n. And isolating this infinite sum, so that's going to be giving us x minus that thing. So basically it's x minus natural logarithm of 1 plus x. I'm so sorry guys, I'm so sorry. So basically this sum is x minus natural logarithm of 1 plus x, right? Yeah, now it's perfectly fine. Okay, so and yeah, let's just talk about this one, this sum. So yeah, okay, so if we talk about this sum, so this sum can be written in terms of like odd terms and even terms as well. So it's negative 1 to the n Riemann zeta of n minus 1 over n and x to the n. So that can be written as this sum as k goes from 1 to infinity, and this is the even term, right? So we would not be having a negative in front, because negative 1 to the n is just positive, right? Negative 1 to the 2n actually, it's just positive. So yeah, and it's Riemann zeta of 2n minus 1, or let's say 2k, yeah, 2k and over 2k and x to the 2k, and minus the odd sum as k goes from 1 to infinity of Riemann zeta of 2k plus 1 minus 1 over 2k plus 1, and it's, look, this is the argument of Riemann zeta function, right? Like 2k plus 1, so you cannot cancel this plus and minus 1. Don't just care about that, dude. Okay, so this is what we are having, right? Okay, and now let me just tell you something here. Actually, we can evaluate this even sum, right? But it's, I think odd sums are not easily evaluable, and that's why we won't be evaluating this odd sum. We would be writing it as it is, but we would be evaluating this even sum actually, and then we'll just plug back every stuff that we will be having after evaluating this one. And yeah, so finally this sum is equal to these two sums, and this one is x minus natural logarithm of x. So if we are plugging back in this equation, actually that represents the natural logarithm of gamma of 1 plus x. So yeah, let me just show you what we are having. Wait. Hey, what's wrong with you? Okay. So yeah, we are having natural logarithm of gamma of 1 plus x equals negative Euler mass equivalent times x, and we were having plus x minus natural logarithm of 1 plus x from this sum of that was going from n equals 2 to infinity of negative 1 to the n times x to the n over n, right? We just evaluated that using the Euler expansion of natural logarithm of 1 plus x. And then we were having these two infinite sums. Yeah, so the sum as k goes from 1 to infinity of the even sum actually, and it's 2k x to the 2k minus sum plus 1 minus 1 over 2k plus 1 x to the 2k plus 1, right? I would have changed my chalk actually. I need a new one. So this is what we are having so far, right? And as I just told you that we have to evaluate this sum, not this one. Actually, we just left it as it is. But let's just evaluate this one. So a equals 1. Riemann zeta of 2k minus 1 over 2k and x to the 2k. So this can be written into two different sums actually, because we can just multiply this actually 2k in this parenthesis, and we would be having two different sums. Something this way. The Riemann zeta of 2k x to the 2k over 2k, and then minus the sum and this x to the 2k over 2k. And we just evaluate, we have to evaluate these two sums in order to get this even sum actually. And let's just do it. That's amazing. So I think I should consider this small sum firstly, and then we will look back to this Riemann zeta sum. So firstly, let's talk about this. So it's negative actually. Let's consider negative as well, and it's x to the 2k over 2k. Okay, again using the Taylor series, expansion. Again, using the Taylor series expansion of natural logarithm of 1 minus u, right? So it's negative. We did use of natural logarithm of 1 plus x last time, but now we are using the natural logarithm of 1 minus u. So it's negative, like minus sum as k goes from 1 to infinity of x to the u to the k over k, right? And dividing both sides with 1 over 2, dividing both sides with 2, that's going to be giving us 2. And if we replace u with x squared here, so it's going to be x squared, and it's going to be x squared to the k, which is x to the 2k. And exactly this is the sum that we have to evaluate. So finally we just got this result, like this sum as 1 over 2 natural logarithm of 1 minus x squared. And we did consider this negative in front, so yeah, we just got rid of that. And now let's talk about this Riemann-Zeta sum, like even arguments. Yeah, that's pretty amazing. And yeah, I would say that the way we are going to evaluate is amazing. I could have used a single video to just find out this sum, but actually I'm just here to solve this one, so to prove this one actually, so I thought let's just do it in this video only. Okay, so basically, yeah, and we are having this thing. Okay, but before that, let's consider this one. Euler's infinite product for sine function. Do you remember, guys, what we were having? It was the product as n goes from 1 to infinity of 1 minus x squared over n squared as sine of pi x over pi x. And I have proved this multiple times in my older videos. Even I'm having a playlist of that as well. So if you want, you can consider watching that. Although I'll paste the link in the description box. So yeah, it's pretty amazing. And I did use the double angle formula and some basic limits to solve this one. So, and I took almost more than 1 hour actually. So that was amazing. So like you would ask me, Aman, why you are using this? And how is it relatable with this Riemann-Zeta? Like what you're talking about? So I say, guys, wait. Okay, so taking natural logarithm both sides in this equation. So natural logarithm of this product 1 minus x over n whole square equals natural logarithm sine pi x over pi x. And why did I do that? Why did I do that actually? Wait a second, let me just copy this down and then we'll just switch up to this board. Although I remember every step, but it's alright. And we're having this sum, this sum k goes from 1 to infinity of Riemann-Zeta of 2k x to the 2k over 2k, and we just evaluated this one as 1 over 2 natural logarithm of 1 minus x squared, right? Yep. So let's just talk about that, and we are good to go with our final result. I think I need something water right over here. Yeah, now it's good. Okay, so we are having yeah. Now let's just talk about this. So taking natural logarithm of an infinite product will lead us to take the infinite sum of natural logarithm of the argument. Basically, this is gonna be even I explained it to you. I explained it to you in my recent like I think it's second last video of mine or maybe last video of mine. I'm not sure, but I explained it to you. And it's this sum as n goes from 1 to infinity of natural logarithm of 1 minus x over n whole squared, right? And equals natural logarithm of sine pi x over pi x, right? Okay, now again using the Taylor series, right, of the one we used recently, natural logarithm of 1 minus u is minus sum as k goes from 1 to infinity of u to the k over k. So for our case, u is x over n whole squared. So basically, natural logarithm of 1 minus x over n whole squared is minus sum, and it's 1 over k, and it's x over n whole squared and k, actually 2k. So that's going to be giving us 1 over k x over n to the 2k. Because this exponent and this one would be like multiplied to each other, so yeah, that's what we are having. So I'm just gonna replace this natural logarithm of 1 minus x over n whole squared with this infinite sum right over there. Yeah, I'm just gonna introduce double sum there, and then we'll incarnate the Riemann zeta. N goes from 1 to infinity, and it's negative sum as k goes from 1 to infinity of 1 over k, and it's x to the 2k over n to the 2k, and it's equals natural logarithm of sine of pi x over pi x, right? And yeah, so negative times this sum as k goes from 1 to infinity of x to the k over k, and times this sum as n equals 1 to infinity of 1 over n to the 2k. Well, we can write this as negative, and just switching up the like this order actually. So it's pi x over sine pi x. Yeah, we can write that. So sort of. And you know what I have done here? I have considered this part inside another like this here, and this one with this reciprocal over there. And guess what? This is your Riemann zeta of 2k. Here we are with our Riemann zeta of 2k, and we are with like this negative cancels out with this one, and finally we are here with our final result, that is we are having sum as k goes from 1 to infinity of Riemann zeta of 2k x to the 2k over k, right, equals natural logarithm of pi x over sine pi x. And guess what? We were having 2 here, right? So we can multiply both sides by 1 over 2. And here we are with this sum, and we can plug this result back over here, and finally we are done. But still not, we just need to do some algebraic manipulations, and then we are done actually. So we are having natural logarithm of gamma of 1 plus x equals, well, we are having Euler minus Euler Mascheroni times x plus x minus natural logarithm of 1 plus x, and we were having 1 over 2 times natural logarithm of 1 minus x squared from the another sum actually that was along with this one. And finally we are having the result of this one, that is 1 over 2 natural logarithm of pi x over sine pi x, and this sum that was the like odd things, right? Riemann zeta of 2k plus 1, let me just write this down, over 2k plus 1 and x to the 2k plus 1. Okay, so yeah, it's 2k, right? And now yeah, let's just do some algebraic manipulations here. Well, we can consider taking out a factor of negative x, or maybe, yeah, negative x actually. So it's negative Euler masker only minus 1x, right? And this is negative natural logarithm of 1 plus x, and this can be written as 1 over 2 times natural logarithm of 1 minus x plus 1 over 2 times natural logarithm of 1 plus x, because we know that 1 minus x squared is 1 plus x times 1 minus x, and since both things are being multiplied to each other, so we can consider writing it in two different added natural logarithms, and plus 1 over 2 times natural logarithm of pi x over sine pi x, and minus the sum, and it's Riemann zeta of 2k plus 1 over 2k plus 1, and it's x to the 2k plus 1. And let me just write some last steps there. And okay, you know what? We are having negative natural logarithm of 1 plus x and plus 1 over 2 natural logarithm of 1 plus x. So we can write that as minus 1 over 2 natural logarithm of 1 plus x. And if we are, like, look, what I'm talking about is natural logarithm of gamma of 1 plus x is if we are combining this one, like adding this and this one. So we would be, like, I'm writing this one actually first. So it's 1 over 2 times natural logarithm of pi x over sine pi x. Okay, and then we are having, negative Euler master only minus 1 times x, and then we can write this as minus 1 over 2 natural logarithm of 1 plus x, and plus 1 over 2 actually natural logarithm of 1 minus x, and then the sum as k goes from 1 to infinity of Riemann zeta of 2k plus 1 over 2k plus 1 x to the 2k plus 1. And finally, if we are just factoring out negative 1 over 2 from these two expressions, so that's going to be giving us negative 1 over 2 times natural logarithm of 1 plus x minus natural logarithm of 1 minus x, and that would be leading us to write that as minus 1 over 2 times natural logarithm of 1 plus x over 1 minus x. And finally, we are good to go with our final result, that is 1 over 2 times natural logarithm of pi x over sine pi x, and minus Euler master only minus 1 times x, and then minus 1 over 2 natural logarithm of 1 plus x over 1 minus x, and minus the sum. Actually, I don't have space there, so I will consider writing it over here actually with our very final step. So yeah, that was a pretty long journey, I would say, and it wasn't easy at all, but it's all right. We did that. So finally, we are having 1 over 2 natural logarithm of pi x over sine pi x minus Euler mascaroni minus 1 times x, and then minus 1 over 2 times natural logarithm of 1 plus x over 1 minus x, and minus the sum as k goes from 1 to infinity of Riemann zeta of 2k plus 1 over 2k plus 1 and x to the 2k plus 1. Here you are done with this. Like, guys, just tell me one thing. Wasn't that amazing? The way we just did all the things. The way we just did everything actually. Okay, yeah, that was pretty long, and we are done with this. Again, guys, if you got to learn something if you got to learn something out of it, please make sure to press the 7 share. And if you have any doubt so far, feel free to ask me in the comments and I'll be there for your questions. And yeah, that was amazing. Goodbye, guys. Take care. Love you. And just enjoy your life and enjoy learning mathematics as well. Goodbye.